Hello, I'm Brian Farrell, and welcome to PACE IT session on the Introduction to IPv6. Today I will be introducing you to IPv6, and I will be talking about some differences between IPv6 and IPv4. Now there's a whole lot of ground to cover, so let's go ahead and dive in. And I'll begin by introducing you to IPv6. So what is IPv6? Well, it is the answer to the question of what do we do about running out of IPv4 addresses. Unlike IPv4, IPv6 will provide enough IP addresses for the foreseeable future. Shortly after IPv4's creation and implementation, the Internet Assigned Numbers Authority, the IANA, which is the organization that is tasked with assigning routable IP addresses, realized that the available IPv4 address space would not be enough in short order. The IANA then set about creating its replacement, and they initially started working on IPv5. Well, while working on IPv5, they realized that it wasn't going to be large enough either. It wasn't going to be sufficient for the task, so they scrapped IPv5 and began working on IPv6. The IANA is confident that IPv6 will function as the replacement for IPv4 for many decades to come. Now, IPv6 works at layer 3 of the OSI model. Layer 3 of the OSI model is also known as the network layer, and its major focus is logical network and host addressing. IPv6's job is to provide logical network and host addresses to devices. IPv6 is a 128-bit binary addressing scheme. The 128 bits are grouped together in sets, with each set being separated by a colon. So it's a colon-separated number. Each set is 2 bytes long. For human readability, the binary IPv6 number is converted to a hexadecimal number, that's base 16, with each hexadecimal number being equal to 4 bits, which can be referred to as a nibble because it is half of a byte. An IPv6 address is 8 sets of 4 hexadecimal numbers, with each set being separated by colons. IPv6 provides for over 340 undecillion addresses. And what do I mean by that? Well, the address space is 2 to the 128th power, which is roughly equal to 340 times 10 to the 36th power. So that's 340 followed by 36 zeros. There's the specific number there below. I'm not even going to begin to try and read that. Now let's talk about IPv6's address structure. Every device receives 2 addresses, a locally significant address and a globally unique address. Let's talk about IPv6's local address structure. The first 64 bits of the local address represent the local network, and the last 64 bits represent the host. The local address structure follows the Extended Unique Identifier, the EUI format, specifically the EUI-64. The 48-bit MAC address is padded with 16 bits to make it 64 bits in length. There is a specific formula for doing that. You just need to know that it's done. Now, IPv6's global address structure is similar to the local structure. The host address is always the last 64 bits and follows the EUI-64 number. The network portion is actually composed of the routing prefix and the subnet for the network. It follows the CIDR convention, the classless interdomain routing convention, with the number following the slash denoting the routing prefix. The subnet is composed of the bits between the prefix and the EUI-64 host address. Now there are some notation conventions that you need to be aware of with IPv6. The 128-bit nature of IPv6 makes it cumbersome to write out and can take up unnecessary space. Because of this, some rules were developed to ease the burden of writing out IPv6 addresses. The first rule is that any leading zeros in a set can be dropped. And the second rule is any single set or multiple continuous sets of consecutive zeros may be replaced by a double colon. So let's look at an example. This is the number that begins with the 2001 colon. We can then drop all the leading zeros. And there you see it's a little bit shorter. But we have three consecutive groups of zeros right there in the middle. Those can be replaced by the double colon. Now you can only use the double colon once. Remember, there are 128 bits to this address, and the only way IPv6 will know how many zeros fill out that double colon is if you only use it once. These notation conventions make IPv6 easier to write out, but it's still difficult for us mere mortals to remember. But it does make it easier to write out. Now let's move on to some differences between IPv6 and IPv4. So now, while IPv6 is the more robust and versatile addressing scheme, IPv4 is not going anywhere soon. With its 340 undecillion possible addresses, IPv6 will allow for every device to have multiple unique addresses, and it will be the networking scheme of the future. IPv6 is actually easier to configure than its older sibling IPv4, especially since it can auto-configure its own addresses without the use of DHCP. However, its adoption has been hampered by the widespread popularity of IPv4. IPv4 is well understood and well entrenched. So IPv4 still remains in place, and network administrators will have to learn how to work with both of them. Now, both IPv6 and IPv4 can use Dynamic Host Configuration Protocol, but IPv6 is easier to manage without it. IPv6 allows devices to auto-configure their own network and host addresses through a discovery process. DHCP v6 is only used when a very specific network configuration is required. While both IPv4 and IPv6 have loopback addresses, that's a specific address that is used to determine if the TCP/IP protocol stack has been properly initialized. The loopback address that they use are different. IPv4 uses 127.0.0.1, while IPv6 uses ::1. Whole lot easier there. IPv4 devices or interfaces receive a single address, while each IPv6 device or interface receives at least two: a locally unique address and a globally unique address, making it more versatile. IPv4 has three clearly defined private IP address spaces, while IPv6 does not. Okay, it actually does have a private IP address space, but it's not really relevant because of the unique local addresses that are created. IPv4 is 32 bits in length and can provide over 4 billion unique addresses, while IPv6 is 128 bits in length and can provide over 340 undecillion unique addresses. In the long run, IPv6 will win out and overcome IPv4. Now that concludes this session on the introduction to IPv6. I began by introducing you to IPv6, and then I talked about some of the differences between IPv6 and IPv4. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon.